Hi, welcome to Intermediate Algebra, section 3.2. Today we're going to be looking at slope of lines, and so hopefully some of this you've seen before. If you haven't, that's okay, we'll make it work. But here we go. So the slope measures the steepness of a line. It's a comparison of how much up and down the line is doing versus how far sideways. So we think of that in two parts, the rise and the run. Now the rise is going to be associated with the y values and the run will be associated with the x values, and that's really important, and we'll see more of that here in just a minute. So again, rise over run. So here you can see I have a line, it has 2 points. To find the rise, we're going to subtract the y values. To find the run, we're going to subtract the x values. So we actually have a formula for slope using that. Remember, rise over run, so y's over x's. y2 minus y1 over x2 minus x1. Now, importantly, those little 2's and 1's, those are just used to distinguish y coordinate in the second point, y coordinate in the first point. So that's all they're there for. They're not something that says, hey, multiply by 2 or do anything weird with it. It's just second point, first point, that kind of thing. So we have this lovely little formula, and you'll notice all you have to be able to do to find the slope is subtract and divide. And that's it. Nothing else. So that should be something that we can all do. All right, a couple of cautions though, because there are some things that really trip people up when they start working with slopes. The first one is, it is y's over x's. Okay, so please be careful. Honestly, one of the most common mistakes is I get this whole formula just upside down. The x coordinates are on the top, the y's are on the bottom. You end up with the reciprocal of the answer you want. That's bad. Let's not do that. Second one, the order has to be the same. Now, in the way I drew the picture, we can tell which one is 0.2 and which one is 0.1. But normally we just have two ordered pairs, and it's anybody's guess which one is 1 and which one is 2. Thing is, it doesn't matter as long as you know which one you're using as 1 and which one you're using as 2. And we'll see that here in just a minute when we do an example. And then lastly, watch out for those negative signs. Okay, you've all been doing enough algebra for long enough that I'm sure you've had many experiences where the negative signs can mess you up. It's a really easy place to get it messed up, so please be careful. All right, so next up we're going to look at a couple of examples of how to find a slope. You can do it off of a graph just by counting the rise and the run if you want, but I really like the formula because I like to subtract and divide. So, all right, here we go. Okay, so I have a couple of examples on the board. Obviously, I'm standing in the way of the second one. That's okay. You'll get to see it in just a minute. It's important to note that sometimes you get ordered pairs like this, just given to you. Sometimes you have to pull them off the graph. Okay, so if you have a line and you can see where it goes through some ordered pairs, you could just do it that way. So let's do these two ordered pairs. I have the ordered pairs 2, 7 and -3, 4. Now, I chose to do the first point as actually what? I called it the second point. You'll notice I did 7 minus 4 on the top. I subtracted my y's. Now, since I started with 7 minus 4, on the bottom I also have to do 2 minus -3. If I switch that up, if I did 7 minus 4 and then -3 minus 2, I would get the opposite of the right answer. And I don't want to do that. So, make sure you just go in the same order and you'll be fine. So 7 minus 4 gives me 3. I'm going to be careful with my negative signs on the bottom. 2 minus a -3 gives me +5. So I get a slope of 3/5. For my second example, -1, 5 and -4, -2. This time I chose to take the second point as the second point. So I did -2 minus 5 on the top and then -4 minus -1 on the bottom. Again, be really careful with all the signs. Make sure the order stays the same, all that kind of good stuff. So -2 minus 5 is a -7. -4 minus -1, that's like adding 1, so I get -3. And then, of course, a negative divided by a negative gives me a positive, so I get a +7/3. And really with slopes, we really like to leave them in fraction form because it's just easier to see and understand, because slope is really a comparison between, again, that up and down, the rise of a line, versus the run, the sideways motion of the line. And so I can see that it's going up and down more than it's going sideways. All right, so there we go. That's a couple of examples. I have 2 more that I want to look at, and then we'll see what else we have to talk about here. Okay, so I have two more examples that we're going to look at here. These are going to end up being horizontal and vertical lines, which are frequently switched in people's heads. So we want to make sure that we know which one is which. All right, so for the first one, we have the ordered pairs 3, 4, and 6, 4. Notice that the y values are not changing, and since the y values aren't changing, if you can picture the graph in your head, or if you want to, you can graph it, this is going to be a horizontal line. As you can see, I wrote that down at the bottom. But let's look at what happens with the slope. With the slope, I do 4 minus 4. Which point is 0.1 and which point is 0.2? I don't know. We can't tell the difference because 4 minus 4 is going to be the same either way. So for the x's, I did 6 minus 3. So this time I end up with 0 on the top and a number on the bottom. So this is telling me to take absolutely nothing and divide it by 3. If you take nothing and divide it into as many pieces as you want, in this case 3 pieces, you still get nothing. So 0 divided by anything is always 0. And if you have trouble remembering which one is 0 and which one is undefined, like we're going to see in a second, feel free to throw it in your calculator. If you get an error message, it's the undefined one. All right, which brings me to my second example. This one's going to be a vertical line. So here you can see my x values didn't change. They both have values of -2. So we have -2, -6, and -2, 12. So I set up my subtraction, 12 minus -6, which gives me 18. And then on the bottom, -2 minus -2. Again, be really careful of those negative signs. If you do it right, you should get 0 here on the bottom. All right, this time we have 18 divided by 0. Conceptually, that doesn't make any sense. It says, hey, take something and cut it into 0 pieces. Okay, so for instance, I have a piece of paper here. Take something and divide it up into 0 pieces. That doesn't work very well. You can leave it as it is and you still have one piece. You can rip it in half. You could burn it and release millions of pieces into the air. But what you can't do is turn it into 0 pieces. So this is what we actually call undefined. Okay, division by 0 is always undefined. It is a vertical line. And again, if you type that into your calculator, it will give you an error message. And so that's a really nice way to know which one is which. So I prefer undefined here for the slope, but your book calls it no slope, and I'll take either one. All right, let's keep moving. So finally, for our last board for this particular video, we have a couple more things to talk about. First, parallel and perpendicular lines. Okay, we're going to see those again later as we go through the chapter, but here we go. Parallel lines. What we know about their slopes is that they have to be the same. The slopes are equal. The reason is really pretty simple. Parallel lines never meet, which means they have to be going in exactly the same direction. If they're not going in exactly the same direction, they're going to meet. Then they wouldn't be parallel. So in order to go in the same direction, the slopes have to be equal, which means if you know the slope of one line, if you have a parallel line, you also know its slope because they have to be the same. Perpendicular lines are definitely messier, a little bit less obvious. Perpendicular lines meet at a 90-degree angle, so nice right angle. For those, their slopes are always opposites and reciprocals. So what does that mean? Well, here's an example. If one line has a slope of 2/3, its opposite then would have to be negative, but the reciprocal means you flip it upside down. So instead of positive 2/3, the other line would have a slope of -3/2. And so that's something that we'll come back to a little bit later in the chapter when we start writing the equations for lines. So keep that in mind because that'll definitely pop back up. So the very last thing I want to talk about is that slope measures what we call a rate of change. And really it's an average rate of change, but we're not going to get too fussy here. So a rate of change just means how quickly is one thing changing in respect to another. So I have this quick little example on the board here. Salary, how much money you make in a year versus the year. Okay, so maybe this is a graph with some information on how much money you made, I don't know, from 2010 to 2020. So here's the thing. Salaries in dollars, years are in, well, guess what, years. So what slope is going to do is we can take the units and we can see what rate of change is happening here. In this case, since slope is rise over run, our slope is going to measure the change in money divided by the change in year. Okay, and so it gives us a comparison and says, hey, how much is my salary changing per year is kind of where this is going to end up. And so these little triangles here in front of the money, in front of the year, that's a delta. And in science, we use those a lot to mean change. So that's all this means. Change in money over change in year. And slope is always, in any kind of real world situation, going to measure those kinds of changes. Miles per hour, that would be a slope. Money per year. Lots of things can be set up that way. And really what's nice about it is it's really pretty straightforward because we just steal the units. So here, since my y-axis had money on it, change in money goes on the top, right, where the rise goes. And the years go on the bottom. So we can always figure out what rate of change is being measured just by stealing the units. So anyway, there you go. Have a wonderful day.